This class we worked out three problems. First problem is an industry takes a maximum demand of 1000 kilowatts at 0.75 lagging. It is charged at rupees 350 per kVA maximum demand. The interest and depreciation charges are 12% of the capital cost of power factor correction, which is rupees 250 per kilovolt ampere reactive. The question is calculate the most economical power factor for the industry. So the formula is the most economical power factor is equal to root of 1 minus y by x the whole square, where x is the annual charges per MD, that is 350 is given, 350 per kVA. Y is the annual charges of phase correction, so 12% of 250, that is equal to 30 rupees. So the most economical power factor is 0.996. Okay, very simple problem. Second problem is a consumer takes a load of 500 kilowatts at 0.7 power factor. The tariff is rupees 350 per kVA. The annual cost of power factor correction is rupees 50 kVAR. Determine the most economical power factor and also calculate the annual saving. Okay. Here P is given. P is the consumer load, that is 500 kilowatts. What is the power factor? Power factor is 0.7. Cos pi 1 is equal to 0.7. Tan pi 1 is equal to 1.02. Cost of power factor correction Y is equal to rupees 50 per kilovolt ampere reactive. The maximum demand charges X is equal to rupees 350 per kVA. Another formula, the most economical power factor, root of 1 minus y by x the whole square. Here cos pi 2 is equal to root of 1 minus y is 50 rupees, 50 by 350 the whole square, that is equal to 0.989. So pi 2 is, cos pi 2 is 0.989, pi 2 is 8.506 degrees, tan pi 2 is equal to 0.15. The leading kVAR supplied by the power factor correction equipment QS is equal to P into tan pi 1 minus tan pi 2. Here P is 500, therefore QS is equal to 435 kilovolt ampere reactive. That is the leading kVAR supplied by the power factor correction equipment. Next we can calculate annual saving on MD charges. So this is 350 per kVA, 350 into 500 by 0.7 minus 500 by 0.989. This is cos pi 1, this is cos pi 2. So annual saving on MD charges is 73,053 rupees. Similarly, annual expenditure on power factor correction equipments. This is rupees 50 per kilovolt ampere. 50 into 435, 21,750. So what is the annual saving? Annual saving on MD charges minus annual expenditure on power factor correction, that is equal to 51,303 rupees. Saving is 51,303. Third problem, an industrial load takes 75,000 units in a year, the average power factor being 0.707 lagging. The recorded maximum demand is 500 kilovolt amperes. The tariff is rupees 350 per kVA of MD charges plus rupees 6 per kilowatt hour. Calculate the annual cost of supply and find out the annual saving in cost by installing phase advancing plant costing rupees 150 per kilovolt ampere reactive, which rises the power factor from 0.707 to 0.9. Allow 10% per year on cost of phase advancing plant to cover all additional charges. Energy consumed per year is given 75,000 kilowatt hour. Maximum demand is 500. So P1 is equal to 500 into 0.707, that is equal to 353.3 kilowatts. Annual cost of supply is equal to maximum demand charges plus energy charges. So this is given 350 into 500 plus 6 into 75,000. So the annual cost of supply is 6,25,000. Cos pi 1 is given 0.707, tan pi 1 is equal to 1, cos pi 2 is equal to 0.9, tan pi 2 is equal to 0.484. Now we can calculate reactive power supplied by the power factor correction equipment. QS is equal to P into tan pi 1 minus tan pi 2, that is equal to 182.30 kilovolt ampere reactive. Now we can calculate annual cost of phase advancing equipment, that is reactive power supplied by the power factor correction, that is QS into the charge is given 150 rupees per kilovolt ampere reactive into 0.1, 10%, 0.1, that is equal to 27,345 rupees. Next we can calculate the reduction in kVA. So original kVA is 500. After correcting, that is, this is P1 by 0.9, that is 353.3 by 0.9, that is equal to 392. 500 minus 392 is equal to 108 kVA. Annual saving in MD charges, that is kVA demand, that is 350 into 108, 37,800 rupees. That is the annual saving kVA demand. So the total saving is, annual saving, that is a kVA demand is 37,800 minus annual cost of phase advancing equipment, that is 27,345. So the annual saving is 10,455 rupees. Thanks for listening.